vaporizer. Okay, the first one is Desflurane Tech 6 by GE, latest Fumida. The second one is by the Draeger. The third one is by the Penlon. Okay. So the functional aspects of Tech 6 vaporizer may be thought of as being composed of two portions. The components constituting the regular function and the other components handling the gases, that is inlet, fixed restrictor, sump shut-off valve, manual variable control valve, and outlet. The gases comprising the background flow follow a path through a fixed resistor and leave the vaporizer without ever having to enter the sump containing the anesthetic. This is a very, very important thing. And the sump is heated as a result. It is pressurized and the output of gaseous desflurane is controlled by a series of transducers, valves, and resistors. The sump shut-off valve opens when the vaporizer is enabled and the anesthetic control dial, that is manual variable restrictor, is rotated to any position other than 0% desflurane as detected by there is an optical sensor in that dial setting which we handle, that the control valve for the dial setting to fix the percentage of delivery. There is a optical sensor which detects what is the position of the sensor, and that is, this is the schematic diagram of this desflurane Tech 6 vaporizer. You can see this is the pressure transducer here. There is the fresh gas. This dark tube is the fresh gas flow, and the sump liquid containing sump is here, which is getting heated, and immediately at the outlet of the sump there is a shut-off valve. Then there is a pressure regulator valve, and this is going to get mixed with the fresh gas flow. So fresh gas inlet is here, and there is a fixed resistor for that. This resistor is important because we can vary the fresh gas flow and still get the same concentration output. So to achieve that, you require a fixed resistor here, and the carrier gas with the desflurane is sent out through this. So the desflurane vaporizer tubing is entirely different, and it gets only blended with that. And the most important component which determines what is the percentage is the differential transducer. If you see in this picture, you will be able to understand better. So this is the gas flowing from the machine flow meter. So it goes through that. There is a resistor here, and there is another separate pathway through which the desflurane vapor is coming. There is a immediate shut-off valve outside the sump, as I told earlier, and there is another resistor. So the flow is happening here, and this connecting tube in between has got what is called the differential pressure transducer. So depending upon the changes between this pressure in this tube and the pressure in this tube, this transducer uses the control electronics to maintain the same percentage of gas. And this is the dial setting which we try to operate and set the concentration that we want. And this dial setting has got an optical sensor which will immediately open up the sump shut-off valve and allow the gases to flow. So that is a very important point. And then this dial has got a groove which will rotate and open up this gap depending upon the percentage that we set. So both these things will then definitely mix the fresh gas flow and the vapor, and then ultimately deliver that. And the purpose of the regulator is to reduce the pressure of desflurane vapor leaving the sump and make the resulting pressure equal to the pressure of the background gas. And this is accomplished by electromechanical system. It was chosen rather than a simple mechanical device for several reasons. One, the ease of achieving the range of vapor, that is between 2 to 220 ml per minute, and the linear pressure flow characteristics, the size constraints, the electronic control permitted warming alarm, that is operational, no output, warm up, alarm, battery low, all these things have to be activated only based on the electromechanical system that is there. If it is a purely mechanical device, these control alarms cannot function. So that is another reason why this output is mainly controlled by an electromechanical system. And the higher flow meter flows produce a larger measured back pressure matched by the larger pressure of disfluorine vapor with the resultant greater flow of disfluorine vapor from the vaporizing matching to increase in the fresh gas flow. So the whatever fresh gas flow you alter, the vapor pressure from the disfluorine tube side will be equally matching to maintain the same concentration. And the dial is graduated in increments of 1% between 0 to 10 and the increments of 2% between 10 and 18. But at the 12%, there is a need to depress. That is one of the safety features. That is, when you give it more than 12%, it is going to be a very high dosage. So when you want to use 14 or 16%, then you have to press the dial a little more to release it so that we will achieve the concentration at that level. So these are all the front panel lightings which you will see. There is no output light alarm or low agent level or warm up alarm battery low. So all these four displays LEDs and one is operational. So 5 LED lights are there. Some examiners are fond of asking how many LED display lights are there in Tech 6 vaporizer. So remember there are 5: alarm for battery, low battery, warm up, low agent, no output, and when it is operational, this green light only should burn and all the other four should be not on. And you have a sighting glass to see the level minimum to maximum, and an arrow here indicates, this arrow what you see indicates it is at 450 ml vaporization chamber, except a full 240 ml bottle of disfluorine, and only one bar. And when it is filled up, you will see, when it is operational, you will see the bars of, instead of the level of fluid, you will see the bar indicate the amount of liquid that is left in. So when one bar is in display, that is an amber LED light is illuminated, accompanied by an audible alarm. This indicates that the main part of the vaporization chamber is empty, leaving only 50 ml in the lower part. So here another safety feature in this we can say is the sump or the chamber where you fill the disfluorine liquid. It has got one reserve sump, and then above that there is a vaporizing chamber sump. So once it completely empty of the vaporizing sump and only the reserve 50 ml is present, then you will get the low agent alarm or with an audible sound as well as an LED display. But still the machine will have, the sump will have 50 ml, but that will not be immediately vaporized. And this is how the lights will burn on when the low output or low battery is there. And the mode of filling this, as I told in the last class, you have to lift this cover and there is an opening, and you have to fix the bottle and then tilt it upside down. So I showed, I think, the picture in the last class. And the safety features, there are several safety features incorporated. A second differential pressure transducer measures the differential pressure in the same place as the first transducer, and the two must read identically or the shut-off solenoid valve is activated and the output of the fluid freezes. So in the earlier picture I showed you, there are two different pressure transducers present, and they should read the pressures identically. Otherwise, the shut-off valve, which is just outside the sump outlet, that will shut off automatically. This guards against zero drift of both transducers. So this is very important. And both resistive thermometer devices, one for the sump and one for the upper manifold, are there. And there is a rotatory valve. As for all pressure devices, a relief valve is desirable. With the Tech 6, this is the comprises of the use of a thermostat for each limb of the main power supply to the sump heaters. So what will happen if the temperature exceeds 57 degrees by mistake? Normally it is about 39 degrees. If it exceeds to more than that and goes to 57, the power to the heater is interrupted so that building up of excess pressure is automatically stopped. So that is a very important thing. So whenever by mistake the heating element gets heated more than 39 degrees and reaches 50 or exceeds 57 degrees, the power supply will be cut off. To ensure that the vaporizer does not deliver desflurane when the anesthetist control dial is turned to zero, that is the standby mode, not only the resistor, that is the groove in the dial, is closed, but in addition, a positive interlock mechanism shuts the sump to shut-off valve also, which controls the output. So the shut-off valve, which I showed in the earlier picture outside the sump, has got uh, so two mechanisms. One, it will shut off automatically if the temperature heats up, or if the interlock mechanism is in zero, then the shut-off valve also will close. And that is the purpose of having the optical sensor, so that when you operate the dial from 0 to 1% and 2%, when you turn the dial on, that is sensed by the optical sensor, and the shut-off valve first opens and then only the gas can come out. So it is a double protection. So at 0%, no vapor will be present outside the sump. And before the control dial valve can be rotated to a position other than zero, the dial release button must be depressed. That is common for all the vaporizers, not only Tech 6, every vaporizer, you have to first press the button and then only you can turn the dial on. And the dial release button is pushed, an optical sensor sends a signal to open the solenoid controlling sump output valve. That is the shut-off valve. An interlock prevents the release button from being depressed unless the vaporizer is in operational mode. And a second button on the anesthetist control dial must be depressed to deliver desflurane concentration in excess of 12%. So from 0 to 10%, you have to have one press of the button, and beyond 12%, it needs to be pressed again. And because the sump shut-off solenoid valve opens only when the vaporizer is operational and thus electrically powered and placed correctly on the back bar of the anesthesia machine, the likelihood of liquid dischlorine leaving the sump when the vaporizer is tilted is reduced greatly. So the tilting mechanism will not make the liquid get spilled into the vaporizing tubes. So that is another important safety feature, and also contains a tilt switch. In addition to that, there is a tilt switch which shuts the sump shut-off valve. That solenoid valve which shuts off the sump is very open, and when the angular displacement of the vaporizer exceeds approximately 15 degrees from vertical, again that solenoid valve will close. So that solenoid valve is a very important part of this machine to prevent any vapor spilling out from the sump into the tubing that is going to get mixed with the fresh gas flow. And it incorporates electronic sensors and display of the liquid level in the sump. The method chosen was rather than visual sighting glass of conventional vaporizer, because the possibility of potential leaks caused by the heated vaporizer liquid anesthetic. So that is why that is looking like a bar instead of the liquid level which you normally see in our other vaporizers. The liquid level sensor is a ceramic covered electrode within a stainless steel tube. This is part of the sump. So the capacitance of this sensor, which forms one arm of the comparator, varies with the level of the liquid within the ceramic covered electrode and the stainless steel tubes. So the electrical signal through the electronic devices, there is a 20 bar liquid crystal linear display on the front of the vaporizer, and when the sump is full, all the 20 bars will be illuminated, and the sump contains less than 60 ml, no bar is eliminated. Because as I told earlier, that 60 ml or 50 ml is the reserve volume that will be in the sump. So the level of the liquid is seen more through the bar display rather than the visual fluid level that you see in the other sumps. A second device switches off the heaters when the sump is almost empty. This is another safety feature. So if the sump is getting dried up, the liquid is not filled at proper time inside of the alarm, the heaters will be turned off so that there is no heating happening to vaporize the liquid. This results in no output alarm. So the method of activating the no output alarm is by the switching off the heaters, which change to a low agent alarm when the rotated dial is returned to a standby position. And there are two mechanisms designed to prevent overfilling of the sump. How you, on other vaporizers, there is a possibility you can overfill the sump. Whereas here, the first is the filler aperture of the sump is placed so that when the level of desflurane in the sump is above the aperture, thus occluding it, the sump is full but not over full. So the filler aperture, as I showed the picture in the earlier class, when the level is above the aperture, it will get filled but it will not get overfilled. Second, the sump outlet is higher than the liquid level of a full bottle of desflurane in its filling position. Thus, under ordinary circumstances, the sump fluid would not reach this point. However, it should be noted that the design of both these mechanisms depends upon the vaporizer being filled in its normal upright position. But if there is a little tilting you have then the possibility of overfilling can happen. And filling the vaporizer while it is in another attitude could bypass this design, resulting in overfilling. However, even if the vaporizer were overfilled when tilted, the solenoid shutoff valve would prevent liquid from leaving the sump. When the vaporizer was subsequently turned on, a small amount of liquid may leave the sump. However, the resulting vaporizer would cause an increased pressure in the desflurane gas channel, resulting in again closure of the shutoff solenoid valve. So from all this description, we can understand that the shutoff solenoid valve, which is very close to the outlet of the sump, plays a very major role in preventing excess desflurane being uh, delivered. So this is how the filling happens, and you can see why it cannot be overfilled. Once you tilt that, it gets full, then no more liquid can flow. So that is the mechanism by which it is not able to, the vaporizer may be, and it can be required while the vaporizer in use also. And output is approximately linear over the full operating range of 0 to 18% weight by volume uh, from the flow rates of 500 ml to even 10 liters. So whether you use a very low flow or a very high flow, and whether you are operating it at various concentrations, the vaporizer output will be same. That is a very important beauty of that. And again, last class I told you why this bottle is peculiarly made like this with a plastic coat, because of the high pressure. Earlier it was designed that it may suddenly break when you drop it or when it is colliding with another bottle. So a glass bottle covered with a plastic coating was the manufacturing method of this desflurane liquid. But the current ones, they are made up of this amber colored bottle because it is photosensitive, and it has got the what is actually described bayonet filling uh, system. So this filling port is sealed with the bottle, and you have to just insert it into the slot and press the bottle. Once you press there is a spring which will get released, and the fluid will start flowing through that. And once it goes and fills to the maximum, automatically it will stop flowing further, and overfilling or spilling cannot happen. So these are the few points that you would like to add to this particular temperature. Okay, shall we go to the next topic?